So that's mean I write n over 2 pi summation xi minus mu naught square over n over 2 exponential negative n over 2 divided by n over 2 pi summation xi minus x bar square n over 2 exponential negative n over 2. Okay, the things that you can cancel out, you cancel out. So that's mean in this case, we will have exponential negative n over 2 a common term. So that's mean you cancel out this one. Okay. Okay, so now ini pun sama. You have n over 2 pi, n over 2 pi, n over 2 pi, n over 2 pi. So cancel out. So rewrite it again. Simplify kan. So summation xi minus x bar square over summation xi minus mu naught square over n over 2. Okay. So I already simplify. Then I get summation si minus x bar square over summation si minus mu naught square. Okay. Boleh kan? So itu that means you take the likelihood ratio. You ambil likelihood for small omega divided by large omega and then simplify, modify, cancel out. So that is the value lah, summation si minus x bar square over summation si minus mu naught square over n over 2. Okay. So now you want to find the critical region. Critical region normally we set less than equals to k. So before that, you check the term here is summation si minus x bar square over summation si minus mu naught square to the power n over 2. Okay. So now, let's say I rewrite. Okay, kita nak simplify kita nak simplify lagi, kita nak cari macam common term. So let's say summation xi minus mu naught square. You can write in terms of summation xi, you add the term x bar plus x bar that we already done before this, okay, to solve for certain question, minus mu naught square. Okay, you just square root. So I think every one of you already know this one. So you will have n x bar minus mu naught square. So kalau siapa yang belum faham lagi, try to expand, simplify, check macam mana yang term tu summation si minus x bar minus mu naught tu we get 0 actually. So we leave you as summation si minus x bar square plus n x bar minus mu naught square. Okay. So now I will replace in this one, summation si minus mu naught square. Okay. So I will replace in your likelihood ratio statistic. Okay, next step. So kita replace this one. Summation xi minus x bar square. Summation xi minus x bar square plus n x bar minus mu naught square over n over 2. Yes, saya replace kat sini. So you have summation si minus x bar square over summation si minus mu naught square. So I replace summation si minus mu naught square by this equation. Okay, so I have this one. Okay, factor out summation si minus x bar square. Okay, factor out. Okay, so you will have factor dulu step by step I show you. So 1 plus n x bar okay. So that's mean you cancel out, so it just leave you with 1 plus 1 plus n x bar minus mu naught square over summation xi minus x bar square. Okay, so it gives you like this. So you have 1 plus n x bar minus mu naught square over summation xi minus x bar square. So this one, let k be the opposite. Let's say, let k be a positive number such that, okay, kita ada this one less than or equals to k. Okay, so I just set this one, saya tulis kat sini dulu, less than or equals to k. So let k be a positive number such that you can take likelihood ratio test statistic less than equals to k. So that means what you already simplify is 1 over 1 plus n x bar minus mu naught square over summation si minus x bar square is less than or equals to k. Sekejap. Okay, so I rewrite this one again. Okay, we rewrite the equation again. So we will have 1 plus, 1 over 1 plus n x bar minus mu naught square over summation xi minus x bar square less than or equals to k. Okay, just now we will have n over 2, so k 2 over n. So hilangkan dia punya square root. Okay, I eliminate the square root, so will become k to the power 2 over n. So let's say this one is your k prime. Okay, so rearrange back. So that's mean kita bawa apa ni? Okay, I just bring this one 1 over k prime less than equals to 1 plus n x bar minus mu naught square over summation xi minus x bar square. Okay, so now we will have, okay, 1 over k prime. Okay, 1 over k prime. So this one, your denominator you bring upwards. So k prime is over here. So just change the equality. So we will have 1 over k prime minus 1 less equals to n x bar minus mu naught square over summation xi minus x bar square. Okay, saya tulis balik we write again. N x bar minus mu naught square summation xi minus x bar square, so greater or equals to, let's say, k double prime. So this one I just set as k double prime. So you will have n x bar minus mu naught square over summation xi minus x bar square greater or equals to k double prime. Okay, sampai sini ada soalan tak? If you have any question. Okay. Ya, kita go back a little bit supaya kamu tak lost. Okay, first, again, we will have your density function. Okay, we check your null and your alternative. Now you have unknown mean, unknown sigma square. So in your small omega, you have parameter mu and sigma square, but the restriction is only on your null hypothesis where we have mu equals to mu naught. So sigma square can be anything which is sigma square greater than 0. So omega is all the value of parameter, okay, because there is no restriction. So L omega, likelihood for omega, you solve, you put the likelihood, you replace mu equals to mu naught. But still we have sigma square. So to estimate, so sigma square, you take the ln, differentiate with respect to sigma square, you get sigma square head is given as summation xi minus mu naught square over n. Okay, after that, You estimate your likelihood for small omega, replace by sigma square, and then simplify, you get this term. Okay. So next step, you compute for L large omega. Okay, large omega, that's mean all parameter values, mu and sigma square. So since both are unknown parameter, you estimate mu head is equals to S bar, sigma square head is just summation Si minus S bar square over N. Okay. So substitute in the likelihood. Okay. So it gives you this one. And then we take the ratio of this two likelihood function. Simplify, we have this term. Okay, ini to the power N over 2. Okay. So to make it more simple, that's mean to reach to the conclusion, I take summation Si minus mu naught square. So we expand, we use summation Si minus S bar plus S bar minus mu naught square. So again, substitute in the value, cancel out. So you have this term. So now your likelihood ratio is less than or equals to K. Okay, less than or equals to K. So we have this one. Okay, K to N replaced by K prime because K ni any constant je, tak ada apa-apa, constant value. So again, you will have the last term, you will have this one. Okay. Up to here, you will have nx bar minus mu naught square over summation xi minus s bar square greater equals to K double prime. So this one, we have to define some variable. Okay, we have to take note lah. So that means if you refer back, what is the value for your sample variance? Sample variance is given as S square. Let's use it dulu. Note that S square is given as 1 over n minus 1 summation xi minus x bar square. Okay, so that means I can write n minus 1 S square is equal to summation xi minus x bar square. So I can replace here. Okay. So that means this rejection region, you can write the above rejection region, so is equivalent to, okay, so I just replace this one, n x bar minus mu naught square over n minus 1 s square greater equals to K double prime. Alright. Okay, so that means we take note that S square is equal to summation Si minus S bar square over n minus 1, which is your estimate for your sigma square head, which is sample variance. Okay, so kita replace, we replace, so you have n S bar minus mu naught square over n minus 1 S square. So to make it much more simpler, okay, kita modify lagi. We modify again. So we take, let's say I leave ni daripada sini. We will have n x bar minus mu naught square over s square. I bring n minus 1 over here. N minus 1 K double prime. This n minus 1 pun is still a constant value. Okay. Okay. So now, let's say it's the same thing if I write x bar minus mu naught over satu-satu dulu lah. Okay. Step by step, so I write down square root n x bar minus mu naught over s square equal to n minus 1 double prime. Okay, I just write down square root n x bar minus mu naught over s, square the value greater equal to n minus 1 K prime. Okay, so this one, next slide, this one, so again you have n, square root n x bar minus mu naught over s, square greater equal to n minus 1 K double prime. So the same thing if I write down x bar minus mu naught s over square root of n as n minus k double prime, which is the same equals to c. So if you remember back, what is your standard normal? Standard normal, you know that your z is x bar minus mu naught over sigma over square root of n. This is your z distribution. What is your t? T is x bar minus mu naught s over square root of n. So in this case, our t is equal to s bar minus mu naught s over square root of n. So that means this is your t distribution. Okay, so this is your t distribution. So that means it's the same thing if I write down. Okay, so since we have square value, x bar minus mu naught s over square root of n. So this one is your t. Okay. So we will have like this is there. So let's say I put this one. Okay. So this one is your t. So that's means t square. So t square is greater or equals to c. So you can write down t greater or equals to c, or t is less than equals to minus c. So that's means we will reject h naught if t or modulus t is greater or equals to c. So this follow the t test. So that means the likelihood ratio test L of t is equivalent to the t test. Okay, so that's complete the solution. Okay, so that means we will have t distribution x bar minus mu naught s over square root of n. So you replace in here, which is we have t squared greater or equals to c. So since we have a square value, so we have two value which is positive or negative. So you will reject h naught when t is greater than c or t less than minus c, or you can put in terms of your modulus, which is modulus t greater or equals to c. So at the end, the likelihood ratio test is equivalent to the t test. Okay, so why it is equivalent to the t test? Because again, your original question is a normal distribution. Okay, normal distribution. It has unknown mean, unknown variance. If you remember back, if you have unknown variance, so that's mean unknown variance, that's mean unknown population variance, you have to estimate using S square, your sample variance. So using your S square, so we replace again your summation is I minus S plus square, and so on. And then it becomes a t distribution. So that's mean in this case, our rejection region is a t distribution. So we will reject h naught when we have t greater than c or t less than minus c.